Okay, question number 11. A coin was tossed 200 times and 115 of these tosses result in heads. You can think about the same question. Remember the Swiss chocolate to and other kinds? This is the same thing actually. You ask 200 people, so 115 of them like this chocolate to and other kind. But right now we have a coin. Alright, use two-tailed test with a significance level 1%. So our two-tailed test something right now right now it's binomial. That means this is discrete random variable, right? It's not continuous. It's not talking about the area. It's something like this now. Okay, you did it. I think that there are 200 times over here. Okay, let me erase that part. Okay, now I'm going to do this test for 0 here. That part is gonna be, let's say, this part and then this part. Those parts represents, let's say, 0.005, 0.005, and this area stands for my null hypothesis, let's say. Okay, here is the H null null hypothesis. What is my null hypothesis? Let's say the null hypothesis say the coin is fair. The coin is fair. If the coin is fair, you can write it down. This is also correct. If the coin is fair, what is your probability? Is 0.5, right? Heads and tails. The alternative hypothesis, coin is not fair. In another way, coin is biased. Okay. Or P is not equal to 0.5. Now what I'm going to do, I will use my binomial distribution probability. So I will go to my calculator. I will show it to you later. Now, distribution, binomial cumulative distribution is data. Lower is 115, upper is 200, number of trials 200, probability is 0.5. So which is equal to, the probability is equal to 0.02. But now this is for one side. This side I looked at it. Let's say here is 115. How do I know it's here? Because it's more than this. So then my probability times 2, right? This is also come from here, times 2, because two-tailed test, 0.04. What is my alpha? Well, my alpha is 0.01. My probability is, my test probability is greater than the alpha. That means my test statistic stays over here, right, or over here. That means I will accept the null hypothesis, which is the coin is fair. There are other two ways. Let's look at the calculator now. The first way we did, actually we went to the distribution, okay, and then binomial distribution, binomial CD, so those are what I typed in, and then look at my probability, 0.02. This is for 1, so 1 part. So 2 parts, I'm going to add them. So this is 0.04, which is greater than alpha. So I accept the null hypothesis. Another way is, maybe you can use a proportional test. Exit, test statistic, Z, and then one proportional test. We think the alternative hypothesis is not equal to null hypothesis. The null hypothesis is 0.5. So you think about it. You ask, do you remember that the previous question we asked 1,400 people and then how many of them like Swiss chocolate? This is kind of the same. We tossed it 20 times and 115 times is head. So click on it. Look at the p-value. Again, it's greater than alpha. So still we stick with the null hypothesis. Null hypothesis 3. True. Another way to do this, you can create an interval. So confidence interval, go to the, okay, again, interval, Z interval, one proportional interval. So you are looking for 99% because your alpha is 0.01. And again, you did it 200 times and you got 115 times. Look at it. lower and upper. What do you think? The 0.5 stays in this interval? Yes, that means still 0.5 is correct. The probability is 0.5 for the coins is still correct. So stick with the null hypothesis.